Welcome to the Science and Technology YouTube channel, your one-stop destination for all things cutting edge. We are all about exploring the newest research, the latest discoveries, and the most groundbreaking innovations that the world of science and technology has to offer. From the smallest atoms to the vast cosmos, nothing is off limits. So, buckle up for a journey that promises to be as enlightening as it is exciting. Today, we delve into the intriguing world of time travel. Time travel has always captivated our imaginations. It's a concept that has been embedded in our culture, sparking intrigue and fascination. We've been enthralled by the idea of voyaging through different eras, witnessing history firsthand, or exploring the uncharted territories of the future. From H.G. Wells' groundbreaking novel, The Time Machine, to the fan-favorite Back to the Future trilogy, time travel has been a central theme across literature and cinema. These narratives have fueled our curiosity, allowing us to ponder on the possibilities and the paradoxes. Would it be possible to alter the course of history? Could we prevent certain events from happening, or ensure that others take place? Even in the realm of comic books and TV shows, from Doctor Who to The Flash, the fascination with time travel persists, reflecting our collective desire to defy the constraints of time. But what does science have to say about it? The concept of time travel is more than just a figment of our imagination. This statement might seem like a premise for a science fiction novel, but hold on to your seats because it's not as far-fetched as you might think. Let's dive into the scientific theories that support the possibility of time travel. The first one we're going to explore is none other than Albert Einstein's theory of relativity. Remember the famous equation E equals mc squared? Well, Einstein's theory goes way beyond that. It suggests that space and time are intertwined into a single continuum known as space-time. And here's where it gets interesting. Space-time can be warped and distorted by gravity. Imagine space-time as a stretched rubber sheet. If you were to place a heavy object on it, like a bowling ball, it would cause a dent. That's essentially what planets and stars do to space-time. They distort it, creating a curve that moving objects follow, which we perceive as gravity. But what does this have to do with time travel, you ask? Well, if space-time can be bent, then theoretically it could be bent enough to create a loop, known as a closed time-like curve. This loop would allow for the possibility of traveling back in time. However, it's not as simple as hopping into a DeLorean and hitting 88 miles per hour. Creating a closed time-like curve would require an immense amount of energy and exotic matter with negative energy density. Both are things we're still figuring out how to harness. It's also important to note that while Einstein's theory allows for the possibility of time travel, it doesn't necessarily mean it's feasible. There are other theories, such as quantum mechanics, that clash with the idea, creating a paradox. One of the greatest minds of our time, Stephen Hawking, had some interesting theories about time travel. We'll delve into his thoughts, and the intriguing world of black holes in the next section. Stay tuned, because our journey through time is just getting started. Scene script. Stephen Hawking, a renowned physicist, had a unique perspective on time travel. Imagine the universe as a vast cosmic tapestry, woven with threads of time and space. Stephen Hawking, an emblematic name in the world of physics, was one to delve into its intricate patterns, particularly focusing on the enigma of time travel. Hawking's theories on time travel are as fascinating as they are complex. He proposed the concept of imaginary time, a notion that challenged our conventional understanding of time as linear and unidirectional. Instead, he suggested that time might be a dimension that we can navigate in multiple directions, just like space. In essence, this means that time travel, at least theoretically, could be possible. Hawking's imaginary time is not about imaginary clocks or unreal minutes. No, it's a mathematical concept, a part of quantum mechanics and the theory of relativity. It's a realm where time behaves like another dimension of space, where the past, present, and future coexist. It's a place where the laws of physics as we know them could be entirely different. He argued that the effects of imaginary time could be observed in the behavior of black holes, cosmic entities of extreme gravity where time as we understand it ceases to exist. He believed that black holes could provide a gateway to other times or even other universes. However, Hawking also warned about the paradoxes of time travel, the most famous being the grandfather paradox. What happens if you travel back in time and prevent your grandparents from meeting? Would you cease to exist? These paradoxes, according to Hawking, could be resolved through quantum physics, presenting a universe that's consistent at all times. Despite the complexities and the seemingly insurmountable challenges, Hawking's theories have sparked our imagination and have significantly advanced our understanding of the universe. So, according to Hawking, time travel could be possible, but how? Time travel isn't as simple as hopping into a DeLorean. It's an intricate dance of physics and cosmology, a ballet where every step could lead to paradoxes or require energy on a cosmic scale. Let's dive into the deep end, shall we? Imagine time as a river. The water's flow is the forward march of time we're all familiar with. To go against the current, to travel back in time, we'd need a force strong enough to overcome this natural flow. That's where Einstein's theory of general relativity comes in. It presents the concept of bending space-time using massive objects or high-speed travel. But remember, we're talking about energy and speed on a cosmic scale, something as of now is beyond our reach. Now let's talk about the elephant in the room, paradoxes. The most famous one is the grandfather paradox. It proposes a situation where a time traveler goes back in time and accidentally prevents his grandparents from meeting, thus preventing his own birth. But if he was never born, how could he have traveled back in time in the first place? It's a tangled web, isn't it? Another challenge is the potential for causality violations. In our world, cause comes before effect, but in a world with time travel this might not always hold. Imagine tossing a pebble into a pond in the future, causing ripples that reach the past. It's a mind-bending concept, to say the least. Despite these challenges, the pursuit of time travel continues to inspire scientists. The prospect of untangling these paradoxes and harnessing the energy required for such a feat keeps them pushing forward. After all, science is all about probing the unknown, about being in a constant state of curiosity. And what could be more curious than the prospect of stepping into another time? So, while we might not be packing for a time-traveling trip just yet, who knows what breakthroughs the future holds? Despite these challenges, the pursuit of time travel continues to inspire scientists. Our journey through time has been fascinating, hasn't it? We've delved into the captivating realm of time travel, a concept that has intrigued us for centuries. We've explored its potential, its possibilities, and the scientific theories that underpin this extraordinary concept. Let's revisit some of the key points we've discussed. We've learned about the science of time travel, understanding that it's more than just a figment of our imagination, but a concept deeply rooted in physics. From the theory of relativity to wormholes and black holes, we've seen how time travel could, at least theoretically, be possible. We've also touched on the incredible contributions of the brilliant physicist Stephen Hawking. His work on black holes, the nature of time and the universe has profoundly shaped our understanding of time travel's potential. We've dived into the mechanics of time travel, exploring the technical aspects that could make it feasible. We've examined how time dilation and the fabric of space-time could potentially allow us to travel into the past or the future. While the idea of time travel is still a far-off dream, the scientific theories and discoveries we've discussed show that it's not entirely out of the realm of possibility. It's a fascinating journey, one that continues to captivate us and push the boundaries of our understanding. Until we master time travel, all we have is the present, so make sure to like, share, and subscribe for more